Hey there, economists. Today I am going to go over how to do lab number 2 for Econ 140. This is our first lab that's going to be dealing with Stata, and I'm going to use the virtual desktop to access it. So it should look a lot like what you're doing, whether you're accessing the virtual desktop or buying the new version of Stata. So I'll go through the whole process and then the step-by-steps of the correlation and Stata lab number 2. So let's get started. Okay, so I've got the lab assignment here, and the first thing you'll want to do is go ahead and connect with your global VPN. You can also do Citrix. There's a whole different process for Citrix, but in my experience, the global VPN has been a little bit more stable. So here's the Citrix workspace, which is another option. And you can go to the SAC State IRT to figure that out. And then the Global Protect VPN is already loaded on my desktop, so it's just up here. And I go ahead and connect, and it will prompt me to use my SAC State login info to connect. And then that way I can get access to the virtual desktop. There we go. All right. I'm going to have to do that update later. So then I want to go ahead and open, oops, not that article. And I have bookmarked the maps to all the computers, the virtual desktop, so you can go here. But you can also just go in and search it like I did the first time. And so there is that video where I show how to access the virtual desktop. And so you just can go to SAC State IRT, and their webpage will have directions on the front page. And then just pick any computer that has Stata on it, and pretty much all of them do. You can always double check by looking here. There's a list of all the available software, but most of the computers in the labs have Stata. And then I'll connect it, and it will open with the remote desktop. And so remember, if you go through the SAC State IRT step-by-step directions, it'll tell you that you have to first download and activate Global VPN, then download and activate the virtual desktop, and then you can access a computer from the computer lab from your own device. So it'll take a second to get set up there. It does take a little bit of time, but that's okay. So it should open up any minute now. And you'll have to log in with your credentials again, which by now you probably all memorized 100 times. And there we go. So as I said in the lab assignment, what you'll want to do is you'll want to generate a log file to submit to me. We talked about that a little bit in lecture. You can also generate a do file for yourself, and that's going to help you keep track of the commands we're using. The other thing you'll want to do, if you haven't already, is go to the Wiley textbook website and look up the resources for the COOP book, and that will allow you to download the data sets that we'll be using for a lot of the labs. You can also download them from Canvas, but it's kind of easy if you just go here to the Student Companion site and download the resources. You can just download the data set in Excel as a zip file, and then all the data sets that are associated with the book will be on your computer, on your virtual desktop, because you won't be able to access stuff that's on your computer while you're in the virtual desktop. So if you kind of look at it this way, you can see I've got my computer here and then the virtual desktop here, which is a totally separate device. So I want to go ahead and open up Stata. And so here's my Stata window. Again, I've got my commands here, the history of all the commands I've done, my output window here, my little command window where I put in my commands, and then my variable names over here. And I'm going to do what I did last time and see if I can't zoom that in a little bit. But the first thing I'll want to do, besides make this a little bit bigger, well, the first thing I want to do is not have this open twice. Is to go ahead and start that log file so that everything that I do today is logged. And so if you look over here, the log file is this, this kind of notebooky looking graphic. So you can click on that and it will ask you where you want to store a formatted log or a .smcl file. And so you can select, where you want to put that. I might put it on my, in my documents. And I would call it, I think I asked you all to call it O219, then last name, and I can save that there. You can also go up here to File and ask it to open a log. And real quick, I just want to remind you guys and specify that log files, you can begin them, you can close them, you can suspend them, and you can resume them. You can't do anything else. You can't edit them. Once they're closed, they're closed. If you suspend it, you can resume it, but those are all of your options. And then you can view them and print them, and you can save them as PDFs, but there's not a lot of editability to log files. They truly just track everything you do. So you can access your do files and anything else in here that way. The other thing I want to do is I want to make sure I've got my downloaded data files, which I believe I have in my working directory. And that's something that you can do if you're going to be doing a lot of work, is you can select a working directory. And that's just saying, hey, this is where you should look for my data, and this is where you should put my files. So I'm going to check if it's in my documents or my downloads. I bet it's in my downloads. Yep, there's my data sets. I'm just going to make my working directory be my downloads. And I'm going to now import the first data set. So the first thing we want to do is import the forest Excel data set, and it's going to be an Excel spreadsheet. So I want to go and see where it is. It's going to take me to my files, and I'm going to say, okay, I want in here this folder full of Coop data sets. You can also just download it, like I said, from Canvas. And there's Forest XLS. I'm going to open that. And I want to remember to import the first row as variable names. And then we'll see, okay, here's the numbers of each observation, the percent change forest loss, population density, crop change, and pasture change for all of those. And I'm okay with that, so I'm going to import that. You can see my commands are all logging here, and there are my variables, and everything is all the way it's supposed to be. So now I want to calculate the descriptive statistics, right? So I'm going to go ahead and I want to get the summary statistics for all the data. And so I'm going to go ahead and click Summarize. And it goes ahead and gives me all of my observations. I have 70 observations for each variable. I have my mean of forest loss is 1.13%. Population density is 639.427 people per hectare. Crop change is 6.9. Pasture change is 3. And then we have our standard deviations. We see that there's the standard deviation for forest loss is pretty similar to the mean, even though there's a pretty big difference in the min and max. The standard deviation for population density is much larger. There's a much bigger spread between the minimum and maximum population density for these countries. And then the standard deviations for crop change and pasture change are pretty similar, even though the means are fairly different. And we see that over here because the lower bound for pasture change is much larger in magnitude than the lower bound in crop change. And so I do ask you to give me a couple of sentences interpreting that. And so the way we can do that is go ahead and I'm going to just kind of make this a little bit bigger so it's hopefully a little bit easier to see. You can do that. You can move things around in Stata. And I'm going to use the asterisk or the little star above the 8 to insert my comments. And so I'll say there are 70 observations in the sample while there is not a huge variation in forest loss between the observed or the sampled countries, there is a lot of variation in population density. And there's not a right or wrong thing to say here. You just want to sort of speak to what these numbers tell us. So any of the things we've talked about, anything else you observe, anything you want to say about what these values, what these summary statistics have to tell us about the data is perfectly fine. Okay? So I'll go ahead and put that in there. And again, you don't want to do too many sentences, but just a little bit there. Got a little typo. Stata does not care about typos. And you can see here, it just kind of runs through like a typewriter, right? It doesn't, it's not very advanced text editing software. That's okay. It's just the way it is. That's not what Stata does best. It does data the best. So that's the first part. We're already moving along, right? Okay. So now I've got my summary statistics. I want to go ahead and generate a correlation coefficient. And again, you can use the full word correlate, or you can just use CORR. And I want to look at the correlation between forest loss and population density. So I can click on these little arrows here and it'll insert the variable names for me, or I can type them out, whatever you're most comfortable with. I go ahead and click that and I get the correlation coefficients for forest loss and population density. And then I want to interpret that. And remember, basically all these correlation coefficients tell us is the strength and direction of the correlation between these two variables. So if I were to interpret these, I would say forest loss and population density are positively correlated, and the strength of the relationship between these two variables is fairly strong. The correlation coefficient does not give us any information about the causality of the relationship between the two variables. Cool. Awesome. And then the last thing I want to do is generate a scatter plot, right? I want to do a 2A scatter plot using forest loss and pop dens. And so it'll just take a second for that to pop up, and there's my graph. And so I can see the distribution of variables. I can see what we saw when we looked at the summary statistics, right? That there's a lot of variation in population density, not a ton of variation in forest loss. We have a little outlier up here, but generally it's pretty evenly distributed. And that gives us, that tells us a lot. We're going to use XY plots going forward to look at regressions in the next couple of chapters. So it is useful to get a little bit comfortable with these. And we'll do it again for the next section. So that is the end of what we're going to do with the forest loss data set. So what I want to do now is clear out the forest loss data. So I have to tell Stata to clear it out, and then I want to insert the new data set. So I'm going to import another Excel spreadsheet. And this is the one that's called H price, or house price. And if you have questions about these data sets, these are used in Chapter 3, and they describe the units and everything that, the units and the measures and everything for these data sets. And that's useful because, you know, we want to specify, like, for example, it's important to know that forest loss is a % change value Population density is people per 1,000 hectares. We want to remember again to import the first row as variable names. Sale price is going to be in Canadian dollars in 1987. Lot size, bedrooms, bathrooms, stories, those are all a little bit easier to answer. And we'll talk more about that later. And so again, the first thing I want to do is generate summary statistics. And I can reuse my old command up here. And I don't want the summary statistics for everything because there are a lot of variables here. That would be a really big table. And so I'm just going to get my variables of interest for this assignment, which are sale price, lot size, bedroom, and bathroom. And so I want to make sure to specify that. So my command here is summarize, and then I have my 4 variables right there. And I'll click enter. And now I get my summary statistics. I have a lot of observations, 546 homes, mean value and standard deviation, the minimum and maximums. And I want to, again, interpret this a little bit. So we can say something like, this is a fairly large sample. Different. Oh. I think it's interesting to look at the differences in lot size. The difference between the minimum and the maximum value is pretty high, and the standard deviation is not as big as the mean, but it's still pretty interesting. It's a standard deviation is 2,168 square feet, so that's significant to me. But again, you can interpret whatever you think is interesting in these summary statistics. It's just summary statistics. I don't think it's so surprising that the mean value for bedrooms is 2.9. Many homes have 2 or 3 bedrooms, and that combined with the mean value for bathrooms number suggests these are smaller homes. Okay, fix that typo. You can also say like the mean sale price is $68,121.60. Now I've interpreted some of that. Cool. We want to get used to interpreting data. As we move forward, I'm going to be asking you more and more to interpret your results. And so I want you to get used to talking about these numbers and feeling comfortable with them, and feeling comfortable with me kind of giving you the open-ended question of interpret the results. Sometimes I'll mean something very specific and I will tell you that, but generally you want to start to be ready and comfortable to talk about data and what it might mean, and make some inferences based on that. The next step we want to do is do a correlation matrix, and we're going to use those same variables of sale price, lot size, bedroom, oops, almost a typo, and bathroom. And now I have this nice large correlation matrix, and I can see this correlation coefficient between sale price and sale price, lot size and lot size, bedroom and bedroom, and bathroom are all 1. And I see some weak correlations here between lot size and bedroom and lot size and bathroom, which is interesting. None of these are negatively correlated. I think that's interesting. I think that makes sense. I would expect everything to be positive, right? Lot size, sale price, bedrooms, and bathrooms should all move in the same general direction. As one goes up, the others should all go up. And so that's something I could say about the interpretation. We could talk about how lot size and bathroom have the strongest correlations with sale price and what that means. I think it's kind of interesting that bathrooms have a stronger correlation positively with sale price than bedrooms. That's kind of interesting. So any of those things that you think are interesting would be something you would interpret in this. So I'll just say the correlation between lot size and sale price is strong and positive, as is the correlation coefficient between bathroom number and sale price. The correlation between lot size and bedroom and lot size and bathroom respectively are fairly weak, but still positive. Cool. All right, so now I've got that interpreted. And then the next thing I want to do is go ahead and generate a scatter plot again. And this time I'm adding something new. I want you to add a line of fit. And so I'm going to go ahead and we're going to start with the same commands. So I want a two-way scatter plot using sale price and lot size. And I want to add on the modification to that command of lfit, and I'm going to call that also sale price and lot size. We'll see how that turns out. Perfect. So now I have this graph here, and I'm going to make it a little bit bigger so y'all can see it. And it shows lot size and sale price. We see that positive correlation. And what I've done now is I've asked Stata to fit a line to this data, basically find a line that best fits this relationship. And so this line is basically saying, you know, all of these points are generally organized around this line. And this is something that's not explicitly tied to correlation. We're going to start talking about it in the next chapter, but it's one extra command to learn, one more thing to do, and it's going to lead really nicely into what we do in week 4 and in chapter 4, starting to look at regressions. So hopefully that's not too complex, and one more nice little thing we can add on. And I can always edit my graph and put in a title. Maybe I want to call it Canadian home prices. Oh, I said something wrong. Okay. Let's try that. Nope. Okay. Well, we'll edit graphs a little bit later. Like I said, Stata doesn't have the most attractive graphs, but they're nice, they're functional, and they can show some interesting relationships. You can do some much more interesting stuff in Excel. That is one thing that Excel does more. Stata's not flashy, it's practical. So I can save this graph if I want to. I would put it in my, let's put it in my downloads. I'm going to call it, I'm going to just give it today's date. There you go. And so now we can go back and look at everything we've done. All of this in the results window is going to be in my log file. All of these commands are everything I've done so far. So if I wanted to, I could copy and paste these into a do file that I could reopen and use over and over again. I've still got my variables in here. But the reality is I'm done. So now that we are done with our project, we can ask Stata to close the log, and that can be done here in the log options. We can close it. We can view a snapshot of it. So there we can see what the log is going to look like. It's got all my results in it, all of my commands, and all of my notes. And then I can go ahead and I can also close the log by saying, oh, wrong command. Let's see, I can close the log here, or I can close it with a command. Log close. Oh, so close, so close. So again, you want to make sure you get your commands exactly right, or Stata will not recognize them. I almost had a perfect log without any errors, but what fun would that be? And now I can go ahead and take this file that I've saved and submit it to Canvas. When you go to close out Stata, it's going to ask you if you want to save your data. So if I go to exit, it's going to say, hey, the data in the memory has been changed. Do you want to save it? There is no reason to save this because this is a data set from the textbook and I haven't done anything that I won't do again, right? I've just looked at the data. I haven't created any new data sets or manipulated it in any way. And so there's no reason to save that data. I have the log. If you have a do file, you want to save the do file, but you don't need the data set because it's already saved in Excel, and so you can always re-import it. So then I can go ahead and close out my virtual desktop, and I'll do that right here, and I'm done. That's it. Lab 1 is complete, or Lab 2 is complete. Hopefully that is pretty straightforward. Let me know if you have any questions. Otherwise, I'll see you next time. Bye.